Hello everyone. So today I'm appearing a mashup contest on Codeforces, which will be consisting of 3 problems, and the time limit will be around 60 minutes. So let's get started. Okay. So here we have a problem, journey planning. Cool. Tanya wants to go on a journey across the cities of Berlin. There are 10 cities situated along the main railroad. Okay, of Berlin, and this city is a number from 1 to 1. Okay, cool. First of all, she'll choose cities one. The journey she'll visit factory. Okay, so on. So cities. Okay. Okay, so there are multiple cities in the sequence, then any pair of adjacent cities. Okay, so basically the question says ki there are n number of cities and each cities are numbered from 1 to n, and basically a person wants to visit each cities in an ascending order, right? And if the person first visits the city 5, then she cannot visit the city 4 after that. Like she has to go visit any city that's greater than 5. So that's one of the condition that's stated here. Strictly it should be increasing. And one of the condition is that like each city will have a beauty value associated with that, and so the difference in the number of the city and should be equal to the beauty value of those cities. So that's one of the condition we need to take care of. And so there is an example given what exactly they mean by it. There are the beauty values of those 8 cities when n is equal to 8, starting from 1 to 8, and there are some additional ways to plan a journey. Okay, cool. Tanya wants her journey to be as beautiful as possible. Okay, so basically she wants to maximize her beauty value provided that this condition is matched, right? Okay, let me just open the page. So the condition is ci plus 1 minus ci equals bi plus 1 minus bi. So this is the condition that she have to take care of. So one of the solution is to go through individual cities, and then compare the beauty values according to the number of the cities. Like if I just choose city 1 and then I'll just go for other cities, I'll just iterate over other cities, and I'll just check their beauty values differences and their and the city number differences with respect to the 1. Once we're done, then we'll move to the second city, and then we'll just continue from that. So basically it will take big of n square. It's like big of n square algorithm. So that's like, I don't think so they will allow big of n square. Yeah, So it's like max is like max, if the max value of n is like 10 to the power 5, so you cannot go for big of n square. Basically it will give a TLE, time limit exceeded, and so that we have to come with some clever solution with it. Okay. So what if I just arrange the equation minus b I plus 1 equal to ci minus bi. So if I do this, so what will happen is that I have to visit each cities, iterate each cities in big of n time complexity, and just subtract their beauty values, and record their beauty values, subtract the beauty values with respect to the number of the city assigned, and then what we can do is and just iterate over other cities and check if we get the same values or not. So that so this can be done in big of n. Big of n, we can just achieve that, and in big of n, so we'll be using a hash map for that. We'll just record the differences, and we'll just keep track of it as to how many such kind of pairs, that originate from the differences of those cities and their beauty values, and we'll just keep incrementing, right? Just incrementing the values at the end. So yeah, let's start with the hash map, and I guess it will just get done with big of n instead of big of n square. So I'll just name it as, let's have some cool name. First I'll start with Ant-Man. Yes. Okay. Now so my class name is Ant-Man, and let's call the template. Now I have to see what are the things are there. Let's see, it's n and beauty values, right? Maximum is 10 to the power 5. We don't have test cases, so here I cannot have test cases. I will just go for it, and wait, it's like beauty array. Okay, so I'll just take those values. Now I'm creating a function calc, just to make a separate calculation, just not to mess things up here in the main class. So yeah, so I've created a function known as calc, or method calc. So yeah, so we'll just check for, we'll just create a hash map. Hash map, I'll just name it as record. Now I'll just iterate over the array. So what I'm going to do is record.put, and the value will be around wait, how much the beauty value can vary. So here, okay, so one thing is that the key in record, it can be negative also. Like if we subtract, chances are that, like if we subtract beauty value minus the respective cities number, so the chances are that the value can be negative, so we don't have to worry about it. And so yeah, beauty value 1, okay, this one, and this is I, the respective numbers. So it's like record dot get a default, same thing, we're gonna take and right. Okay, sorry. And the default value will be 0, and if there is some same differences in the beauty value minus this city number, then we'll just increment the values with the recorded values. So what we have with this is we have to just add record. No, wait, we have to add, yeah, we have to add the beauty number. Yeah, so this way, and one more thing is this really simple solution. So we don't want to iterate over the values after that. You're using another for loop, so just get it done here. Math.max answer, and it's like record dot get, I guess, right? Yeah, minus I. So let's run it. Let's see. So let's check if it's okay. Checking all the sample test cases if it's right. Okay, so far so good. Okay, just checking for any edge cases. Did I miss any edge case, anything? Okay, so anything that I missed, anything? Yeah, this is pretty obvious to me. So just get it done. Let's see. Yeah, I'm sure it's gonna be accepted. Yep. So moving to the next problem, this national project. What is that? So national project is, okay, so your company was appointed to lay new asphalt on the highway length, and you know that every day you can either repair 1 unit of the highway. Okay, or skip repairing. Cool. Skipping the repair is necessary because of the climate. Okay, it's periodical, G days. Good. high quality pavement. Whether during B days is bad, so it can be low quality pavement. Cool. Make sure that you're starting preparing at the start of a good signal. Okay, so you'll be only starting with a good signal. Good. We don't really care about the quality of the highway. You just want to make sure at least half of the highway will have high quality pavement. Cool, cool, cool. Okay. See. Mhm. Okay, so this problem is about a national project. It's just laying asphalt over highway of length n, and so there are basically two conditions. The first is you want to make sure that at least half of the highway will have a high quality pavement. So high quality pavement we can achieve when the climate is good, and so we have to make sure that whatever the maximum number of days to repair the whole highway it takes, so in that answer we must have at least high quality pavement, that is at least so that equals to what do you call this, good number of days. For example, if n equal to 5, then at least 3 units of highway should have high quality, right? And if n equal to 4, then at least 2 units should have high quality. Okay, cool. Like at least half of the should have high quality. And now, how do we achieve high quality? It's that when the weather is good and when the weather is good, we can achieve high quality, and at the same time there are some good duration is given. Like if the weather is good, so it stands for G, and if it's bad, it stands for B. And then so basically these are the duration, like G and B are the duration of the good days. Like we will always start beginning the pavement starting from the good days, then it will be followed by bad days, and then again it will be good days and bad days and so on. So it's just first we'll go for good days, bad days, good days, bad days, good days, bad days, and so on. So this way we can do it. And what else? And the second condition is that the whole highway have to be laid with new asphalt, right? So that's one of the condition. Like one of the conditions is like two condition, at least half of the highway should be have good pavement, and the second is the whole highway should have be done. Okay, so let's say like you have good number of days. I mean, when I say good number of days, I mean duration of the good days, let's say it's 2, and a bad day duration, let's say it's 3 days. So while beginning the work we'll just start with the good days. So like let's say it's 2 for the good days, now followed by bad days. So bad day duration is 3. So it's like the last bad day will be 3 plus 2, it's 5, right? The 5th day will be the last bad day. Then we'll just start with the good day again. So the good day duration is 2. So we have to add 5 plus 2, that's again 7. That 7 is the last bad day, sorry, last good day. Then we'll have the bad day, that is duration is 3. So we have to add 7 plus 3, it's 10, right? So again we'll be going for 2, that's 12, and then again it's 15, and so what we can do is we have to know that how many so one of the ways like calculate each good day, and then move to bad day, then move to a good day, then move to a bad day. This way it will take whole lot of time to calculate, because it's 10 to the power 9 and we have to get it done. I guess this algorithm cannot run on bigger than big of n. So we have to find a algorithm that's less than big of n itself. So this way, if we just go on and on, just checking bad days, and then let's say 2, then we in our answer will add 2. Then we have to add bad days also, because it's a, now remember, we have to add duration. It's like 3. Then we have to again increment, when we are here we have to increment again good days, so it's like 2 and so on. So it's 3. Like it's like these numbers are coming by subtraction. Like how 3 came is like 5 minus 2, it's 3, and how 2 came is like 7 minus 5, and 3 is like 10 minus 7. So that way. So in this way, if we go, it will be really, really, really lengthy. So we don't want to do that. What we're gonna do is we just gonna simply calculate the value directly in a constant time. Let's say it's the required number of good days, so we'll just divide it by good duration, right? So we'll just divide it by good duration, so we'll get an estimate idea of how many pairs of good day and bad day is required, and we'll just add it to the answer. And then after that, so we'll basically get the pairs of how many good days and bad days we can do. It's like it will be in some constant time, big of some constant time. So we don't have to go through like in a naive way of doing it. So yeah, so let's start the solution. So it's like, what should I name it? I guess Batman. So taking inputs, and then okay, we have to check whether it has test cases. Okay, we have test cases, and we have, okay, so length, good days, bad day duration. Okay, cool. So go with the length. Length stand for the length of the load, right? Then we'll go for good duration. Yes, sometimes it's if we just write G, it makes sense, but I like to write in a brief manner, so that like sometimes the if program is really lengthy, so you don't get confused in the middle, right? You'll get to know what exactly. So I just prefer whole words than abbreviation. So it's like, I'll just create a function known as calc, then I'll just go for good duration, give a parameter bad duration, and then create a method or function. Yeah. Okay, so one more thing is that there is a catch. Catch is, let's say, if okay, first we have to calculate the required, so that we can know what is the required. The required equal to length plus 1 divided by 2. So okay, divided by 2 by 3. Yeah, so we have the required value. Now what we can do is we have one more condition we have to follow, is that key. What if the required value, whatever we have, is less than or equal to good duration, right? If that be the case, then we'll just print this required. Or else what you can do is so as we have discussed, we have to divide required by good, so that we can just get an estimate of how many good and bad day pairs we require out of it. So it's just required divided by good duration, right? this will give us the number of good duration can be, is there in the required, and then we'll go for addition of this good and bad duration. Now what if the modulo of this is 0? So that means we have good day and bad duration, like we have matched the criteria, our solution is done. But there is one more thing we have to encounter here is key. Let's say in this example the required value was 4, right? So it's like 4 divided by good duration, it's like 2, modulo is 0. So what does this mean? It's like 2 times of 3 plus 2 good plus bad duration is equal to 5. It's like total answer is 10. But this is wrong, because that means that we have calculated good duration, we have calculated bad duration in this answer, and also one more good duration, but one more bad duration is also added, because we are adding number of pairs, right? So we have to subtract the bad duration from here. So that's what we have to do here is key. We have to subtract if answer, sorry, no, not answer, is like let me copy it, paste it, modulo, right? If this modulo equal to 0, so what we're gonna do is like answer, because we have calculated something in advance, so we have to make bad duration, like we have to subtract it. Else what you can do, else let's say our modulo is not 0, that means we have something need to be added to complete the required, something need to be added, so we'll just add it. Simple. Something need to be added means we have to add it. So just add this required modulo. You can just name a variable of required modulo good duration, because we are just using it multiple times. So, or else you can just do this way also, no harm. Okay, so we'll just print the answer. So I guess pretty much that's it. Anyway, so yes, so you have to, I guess you have to go through this, what do you call it, answer equal to math.max, and this is answer, right? So this should be applied, and after that you can just print this out, right? So this is pretty much, I hope so. And let's see how it run some sample test cases. Wait, what is going on? Okay. Wait. Okay, yeah. Okay, no issues. So this is 6. So let's shift to the problem and let's see how it goes. So just click one. Okay, sorry. should be length. Why did I change that? Okay. Pretty much that's it. And let's see. So let's run and let's submit. Okay, it's accepted. So we can move on to the next problem, and that's pretty much rotation matching. So in this problem it says that after the mysterious disappearance of Ashish, his two favorite disciples, Ishika and Hide, were each left with. Okay, that's not required. Okay, note that the permutation of n elements in a sequence of numbers. Okay, I know that. The message can be decoded by an arrangement of sequence A and B such that the number of matching pairs of elements between them is maximum a pair of elements. Okay. Okay, so it basically says that you will be given two arrays, and you have to find number of matching pairs. Number of matching pairs means in those arrays, the elements in them, if they match with each other, they match. This is the first condition, and if they match with each other, you have to make sure that they are on the same index with respective to their arrays, right? So these are the two conditions as we mentioned. Okay, so his two disciples are allowed to perform the following operation in a number of times. So we choose a number k and cyclically shift one of the permutation to the left or right k times. Okay, I cyclic shift left permutation of C operation, let's say C1 tends to, okay, C1 will be in C1 will get C2, C2 will C3, and C and C1. Okay, so it just says that you have to choose a number k arbitrarily, and you have to cyclically shift one of the array, with respect like you have to right shift with respect to the other array or left shift with respect to the other array, just to see how much the maximum number of pairs of elements we can match. So okay, so it's n equal to this. Okay, good. So what we can do here is rotation matching. It's really trivial, but if we think in a way here, you have just one array and the other array, so you just rotate each element once, and like if we rotate n times in clockwise, let's say, or we can go anti-clockwise, it's our choice. So like if I go n time clockwise, and with each element, if I just rotate it by 1 unit and then check the entire array, after rotation, and match how many elements are matching, that way you have to first, for each rotation, you have to go big of n, and at the same time in those big of n, you have to go for big of n times of matching. So it's like big of n square, right? So the naive approach will give big O of n square algorithm. So that's like, it's really, we don't want to do it because of course nobody is gonna allow you to do with big O of n square, because it's like 10 to the power 5. So it will just have an obvious time limit exceeding. So, or TL in short. So we have to get a really effective way of doing it. So so either we can go with some, let's see, so if it's like to 1 and this is 1, 2, 3, 4, and this is 5. What if you just take the differences of everyone? 5 differences in their index position in their respective with respect to the other array. 4, if we just take the differences of their positions, and because no matter how many times we rotate to the right or left, but once it is like, once we get to know the differences in their indexes, and what happens, like when you know the differences, now I'm pretty sure that there can be some differences that's matching, right? Like the differences in the 5s or 2s can be matching, right, with each other. So that means a maximum 2 elements can be matched. So what we do here is like we just first calculate the differences with respect to each other, and then we just keep a track of it. Like we just count it, we just count the frequency of the differences, and the highest frequency or the highest occurrence of a particular difference, we'll just mark it as an answer, because we need the maximum number of matching and we'll just get it, right? So here we go, rotation matching. So we are done with Ant-Man, Batman. So we'll go for Catman. I don't think so Catman exists. It's like Catwoman, but let's deal with it. So okay, so there is no test cases, so it's better just get rid of it. Okay, so what you can do is like instead of matching it or taking the differences, because our indexes are the main thing we require, so why not just record the indexes with respect to the answers, right? Record the, like, let's say if we have 5, then I'll just take 5 and just record it index. So for that we have to first check how many, the max value of n is 2 to 10 to the power 5, so just increment 1, array 1 int this is 2 times, okay, 5 plus 1, just to be safe, because what if n number is exactly 2 to 10 to the power 5, so if you declare a size of 2 to 10 to the power 5, then that number cannot sit in that box. So we have to actually, just for being safe, just put an addition 1. Yeah. Right. So now what we're gonna do is we take the value and we just keep it the indexes, right? So that will work. Same goes for the second array. So creating a function known as calc, and we just take all those things we require. Array 1, array 2 as parameter, create this. So function has been created. So let's see, is everything's done? Yeah. So what you're gonna do is like create a hash map or tree map. I'm gonna take some tree map. We can also take hash map, depends. Sorry, what are you gonna do? Okay, so what you want, just name it as record. It's So int I equal to 1, I less than equal to n. It's pretty easy. And so our element ranges from 1 to n. So we'll be starting our I value from 1 to n, and we'll just see whether the difference is right. So let's say now here's a thing which is key. Let's say if I take 4 as for example, then in this array the 4 position is 1, and in this array the 4 position is 3, right? So we can just easily say that difference is like 3 minus 1 and so on, right? Provided that when the number is greater or the index is greater than the previous one with right next to the first array. So here will be a condition if so for that I'll just keep a record index 1 equals array 1 and just taking I, yeah, it will just give the index or the same number. Here is 1 starting with 1, so yeah, array 2, this will give you 1. Cool. So here we can do what we can do is like when we have index 1, index 2, now it's time for checking. Now if index 1 is less than equal to index 2, so simply what we can do is record.put, and we will just subtract index 2 minus index 1 because that's a difference, there's a gap, right? And then again record.getDefault, and we'll just taking same index 2 minus index 1, and by default value it's like 0 long. And okay, so what should be the value incrementing? So we want to just count the frequency of it, like how many frequencies. So it's like +1. So let's done. Or else what we can do, the else condition here it is key. What if, like if I just say if I just take let's say 2, right? In this array the 2 position is at 3, and in this array the 2 position is at 1, right? So what's the difference? So you can say it's the difference is like so how do we calculate the difference? Our reference point is the first array, so we are calculating clockwise. So we cannot see this way, we should not see this way, we have to see this way in the clockwise direction. So this is this is one difference, and then we'll just move back the second difference, and this is third difference, right? So this way we'll just calculate. So better is like int temp equal to which will say n minus index 1 plus index 2. That will give us the correct differences in clockwise direction. So now just record dot put temp and record dot getDefault, that's temp and long value 0l plus 1. So yeah, okay. So one of the most important thing is like we don't want to iterate again a for loop and do big of an thing. So what you can do is like just take some answer. Let's say our answer maximum value is represented by answer. So just do this. Either you write it in this way, or just you can just just do it at once. It's like answer equal to math.max max answer, comma, and what you get. Now why can't do this way? We have to put in because there are some differences. So it's like answer, and this is like record.get, and this is index 2 minus index 1. Alright, so here you go. math dot math answer and select record dot get done. Right. So most probably it should work. Hope so. So it's Catman. Okay. Where is Catman? So just checking if it's working. Okay, so far so good. Cool. Sample test cases are running. Checking for the third one. Okay, hope so it's right. And just let's say just Catman. Submit. Yep. We got accepted. Cool. So that was all about, and yep. So we're done with the 3 problems, and yeah. Okay. So contest is still running. So we're done with that. Okay, so those problems are pretty easy. There's not some hard stuff out here. It's like pretty easy, and yes, and so we'll be posting more coding videos, tutorials, especially in future videos. I'll be doing those stuffs too, and yeah, till now. Goodbye. See ya.